Hello students, myself Dr. Divya Ghildiyal in continuation with my lecture series for AKTU BTech second year Energy Science and Engineering. I am continuing with my lecture on solar energy. Please do subscribe to my channel in order to receive a fully solved model paper before your final exams. So in solar energy, what all did I brief you in the past? I told you about an introduction of solar energy. I briefed you the very causes of how sun's rays reach the Earth's atmosphere. What are the different measurement aspects I should keep in mind before I design any building, office, or place, keeping in mind how much sunlight will reach this place. Then I told you about direct and diffused radiation, how solar energy is measured, that is the pyrometer, pyranometer, and pyroheliometer. They are instruments that are used to measure the sunlight. Then I told you about diffused and direct radiations in detail, units, what are the essential important parts of a solar system setup which I have to do. Then I introduced you the basic physics of semiconductors, about p-type, where holes are the majority carriers, n-type, where electrons are the majority carrier, p-type are formed with the addition of trivalent impurities like aluminium, etc., and n-type are formed with the addition of pentavalent impurities like phosphorus, etc. Now, I told you the intrinsic semiconductors are known as the pure ones, and the moment I add impurity, they become the extrinsic or impure semiconductors. Two types are there in your syllabus, the p-type, that is the holes, and n-type, that is the electrons. This question is important. It has been asked twice in your AKTU paper. After that, I briefed you about if I take a metal and a semiconductor and I combine both of them, then it becomes metal semiconductor. Here, metal semiconductor, how it is formed. This also is working just like a PN junction only. Now I will tell you PN junction. When I join a p-type material of holes with n-type material of electrons, what happens is that holes are positive, electrons are negative. Immediately they both will get attracted towards each other, and the electrons will depart from the N region and the holes from the P region. After that, they will start accumulating at the point of combination where the P and N has been combined. The thin layer of the crystal lattice between these charges has been depleted of majority carriers known as depletion region. And here, look at this diagram. It is having electrons excess here. This is having holes in excess. When I have combined p-type and n-type, here a depletion region of extra charges is formed here near the combining point. In contact are having single crystal of p-type has been joined to an n-type. This separation of charges at the p-n junction constitutes a potential barrier. This potential barrier must be overcome by an external voltage source so that we get continuous current from this PN junction. Actually, this will be used in the photovoltaic cells. That is why you are being told about this concept. When the battery is arranged such that the negative is connected to the n-type and negative is connected to n-type and positive is connected to the p-type, then this becomes a forward biased PN junction and continuous current will flow here. When the reverse happens, that is n-type is connected to the positive and p-type to the negative, this becomes reverse bias junction and very small current flows through it. You studied this because you have to study photovoltaic devices in solar energy chapter. What is a solar cell or a photovoltaic cell? This is an electric device that is converting the energy of light falling on it directly into electricity with the help of photovoltaic effect, which is basically a chemical and physical phenomena. When sunlight falls on this photovoltaic cell, it converts it into electricity. So this device, when exposed to sunlight, will convert it into electricity. So solar cells are described as being photovoltaic, irrespective of whether the source is sunlight or you have taken up an artificial sunlight. They only need some light to be incident on it and the process triggers off. In addition to producing energy, they can also be used as photodetector, detecting light or any other type of electromagnetic radiation like visible region, ultraviolet, etc. The photovoltaics are responsible for my solar cells. Solar cells are described as photovoltaic irrespective of the source being any sunlight or artificial light. Now they are the 3 generations of solar cells. The first generation is the old traditional famous semiconductor silicon, which is used more compared to germanium in the lab. Silicon is easily available, cheap, and its band gap also does not create much problem in being maintained in the lab. So the first generation photovoltaic cells are the polycrystal and single crystal. Second generation go more for the amorphous single silicon, and the third generation come up with new technologies like polymers, quantum dots, small molecules, etc., which are more into the research. This is important 10-mark question. So now I will tell you what you are supposed to be writing to get 10 marks. First, draw this diagram. Right here, first generation, second generation, and third generation. The operation of photovoltaic cell requires 3 important attributes. First, absorption of light. Like solar panels, they absorb sunlight and then they work. If your cell fails to absorb sunlight, it is useless. So very first thing is that its absorbing capacity should be high, so that what happens is the moment it absorbs energy, it starts generating electron hole pairs which go in for excitation, and the separation of charge carriers should be of the opposite types, that is the plus and minus, and they should be kept in mind that plus should be going to the plus terminal and minus to the minus terminal. Traditional solar cells are made from silicon. You remember germanium silicon semiconductors, the old ones, they are known as the first generation. Silicon solar cells are longer lasting, and they are the traditional ones, but their efficiency is low, and especially at high temperatures. Silicon type, you can categorize it into more broad category as monocrystalline silicon cell. Mono means one, the oldest solar cell, which was the most popular and efficient because they are very easy to maintain and they can be left in the outside also, and damage caused is very less. The cells are a few inches across and the number of cells are laid. Relative to the other type of cells, they have very high efficiency, means that you can generate more electricity from a given area of panel. Polycrystalline, poly means many. So it is cheaper to produce silicon wafers in molds from multiple silicon crystals rather than from a single crystal, as the conditions for growth do not need to be as tightly controlled. Poly is less efficient compared to the single one. Amorphous means powdery, chemistry. That means now I have made this silicon into a powdered form. So instead of growing the silicon crystals, we have taken it in an amorphous form, and several layers of silicon are doped in slightly different ways to respond to different wavelengths of light. Like suppose some days sunlight is not at its full strength. We are receiving only few radiations on the earth. Then my different layers will correspond. Maybe some will correspond good to the UV, some will correspond good to the IR, some will correspond good to the radio waves. So they have just been done in layers. But the disadvantage is that they are less efficient. Advantage, no doubt, is that they are flexible to various wavelengths. Hybrid again, word means combination. Hybrid are better efficiency, longer life, and reduced cost. Second generation of solar cells are made from semiconductor materials, only a few micrometers thick. They are three basic types of second generation silicon cells: the amorphous ones, the combined ones. In chemistry, you must be studying about this, that when you combine them together, they are not single right now, like just silicon is not there. See, copper, indium, gallium selenide, copper, indium, gallium diselenide. These come for the second generation. Amorphous silicon yields a higher band gap of 1.7 electron volt in comparison to that of the traditional 1.1 of silicon. This allows stronger absorption in the visible region of the spectrum, but it is less matched compared to the infrared. So this flexibility is there. No doubt, disadvantage is low efficiency and stability issues. This is a very common disadvantage which you can mention. Gallium arsenide. See, gallium and arsenide have been combined together and they result in the very high efficiency. But cost is not a limiting factor here. See, they are used in satellite applications. Third generation, you can say that they are going more in for research work. That means new research is going on for the third generation solar cells. But in general, you can mention that they take many multiple technologies like polymers, quantum dots, multi-junction cells, intermediate band solar cell, hot carrier cells, etc. And they are combining the new generation of research work. They no doubt include the silicon nanostructure. Nano is 1/9, nanotechnology, nanoscience, excess thermal generation, to enhance voltage of carrier. This new generation of solar cells are being made day by day from large variety of combinations like nanotubes, silicon wires, quantum dots, organic dyes, etc. So this is more into the research. See, first generation, monocrystalline, mono means one, poly means many. Second generation, amorphous, cadmium telluride or cadmium sulfide. Third generation, organic, polymer or quantum dots. What are the advantages of solar energy? Firstly, it is non-polluting. Electricity and any other source of energy, the biggest drawback is pollution, like ACs, they pollute the environment. It is non-depletable. Sunlight you are getting daily. It is a free fuel which we are just taking from the sun without paying anything. It is reliable. We know sunlight will be there at any cost. Disadvantage, no doubt, is how much of solar energy I am able to convert for my usage. The more surface area I expose, the higher I will get the conversion. But if it's a cloudy day, natural calamity like rain, thunderstorm, humidity, etc., and full sunlight is not able to reach the earth, then it becomes a big disadvantage. The important questions are, what is direct radiation? That we are getting directly from the sun without diffusing. N-type have more of electrons, and the P-type have more of holes. Junction diode, when we combine N-type and P-type. Depletion layer, when the charge carriers, the moment I combine a P-type and N-type like this, the holes will rush towards the negative charge will rush towards the positive charge, and there will be a slight excess of charge carriers at my junction point. Essential characteristics of solar photovoltaic devices: they are characterized into 3 generations, and they are dependent on solar energy. Semiconductor cell. One numerical: find the resistivity of an intrinsic semiconductor with intrinsic concentration of 2.5 into 10 to the power of 19 per meter cube. The mobilities of electrons and holes are given. The resistivity formula is 1 upon sigma is equal to 1 upon NIE into mu n plus mu p. You have been given these standard values, just put them in the formula and you will get the answer. Quickly, I will revise full solar energy with you fast. Incident angle, angle between incident beam and normal. Latitude angle, subtended by the radial line joining the place to the center of Earth. Declination angle, made by the line joining the centers of the sun and Earth with its projection on the equatorial plane. Hour angle, angle through which the Earth must be rotated to bring the meridian of a point directly in line with its sun's rays. Zenith angle, vertical angle between the sun's rays and line perpendicular to the horizontal plane through the point. Also, you can say it is complementary angle of solar altitude angle. Solar constant, section A question: the rate at which energy is received from sun on a unit area perpendicular to the rays of the sun, approximately 1367 watt per meter square. Amount of solar radiation that should reach the earth varies according to geographic location, time of the day, season of the year, landscape, and local weather. 2 devices used for measuring solar radiation: pyronometer, which has a dome shape structure, and pyrheliometer, which uses direct solar radiation. Difference between direct and diffuse is: direct has a unique path, diffuse has a scattered path. Direct is intense, diffuse is not intense. Direct depends less on the atmospheric condition, and diffuse gets more diffused with the atmospheric condition. And when sky is clear, I get a good direct radiation. When sky is not clear, diffuse radiation is all the more horrible. Semiconductors are classified into intrinsic or pure, extrinsic or impure. Extrinsic or impure consist of P-type and N-type. Further, law of mass action states that N naught into P naught, where N naught and P naught are the electron and hole equilibrium carrier concentrations, is equal to Ni square, where Ni is the intrinsic carrier concentration. Silicon is preferred material in semiconductors compared to germanium because the band gap is 0.7 electron volt. Thermal pair generation is smaller, and the formation of silicon oxide layer is easy. Silicon is easily found in nature compared to germanium. Its noise is less compared to germanium. Solar cell or photovoltaic cell is an electrical device that converts energy of light directly into electricity. 3 generations of photovoltaic cell are there. First generation are the mono ones, that is single crystalline structure or the polycrystalline structure. Second generation are the amorphous ones combined with, say, cadmium sulfide, cadmium Te, third generation are polymers, quantum dots, and research is going on this. The most important part in solar energy is the angles and the conditions for best solar light to reach the earth, the two types of measuring instruments which help us in measuring the solar radiation, semiconductor physics, p-type, n-type, their differences between direct and diffuse radiation, and discuss in detail the three generations of solar cells, first, second, and third. Thank you.